All right, ladies and gentlemen, today we're going to be talking about sequences, specifically geometric and arithmetic sequences. Let's get started. First of all, what is a sequence? Well, a sequence is a set of things or events that are in an order, okay? You've learned sequencing in reading. Well, this is sequencing in math, and in our case, it's going to be a set of numbers that are in a specific order. All right, so we have a set of numbers here: 11, 13, 15, 17, ... Okay, well, the first term of our sequence is 11. The second term of our sequence is 13. The third term of our sequence is 15. We have a fourth term of our sequence, and that's 17. And then we have the ... The ... is called an ellipsis. An ellipsis means that that set is going to continue on forever and ever. All right? Now, you may hear the terms called elements or members of a set, but we're going to refer to them as terms. All right. So we have a couple different notations. The notation we're going to talk about today is what we call subscript. And so if I have A sub 1, now notice how the letter A is written and the 1 is a little bit below the A. That's because it is called subscript. And when I write that, all right, I'm going to write my A, and then the 1 is going to be a little bit below it. If you're using lined paper, the 1 can be on the blue line or a little bit below the blue line, and that's called subscript. When I say it, I say A sub 1, and I want you to write that down, please. A sub 1. Don't write it as A1. We're not referring to steak sauce. Okay? A sub 1. Now, we have learned another way to write this a long time ago at the beginning of our school year, and we wrote it like this. And if you remember, that's called function notation. And function notation, when I put in a 1 instead of an x, that is another way to refer to the first term of my series. Okay? But again, we're going to do subscript from now until the end of this video. And so what if I don't know the term and I want the nth term? Well, I'm going to write that as A sub n. A sub n means the nth term of my set or of my series, okay, or of my sequence. All right. So the first kind of sequence we're going to talk about is arithmetic. Arithmetic. Okay? An arithmetic sequence is a sequence that has that each term is changed by a common difference, meaning it's changed by the same number. I'm either going to add or I'm going to be subtracting to get from one term to the next. And I'm going to be adding or subtracting the same exact amount. All right, so let's look at our original sequence, 11, 13, 15, 17. So how did I get from 11 to 13? Well, I can add 2. So if I add 2 to get from 11 to 13, can I add 2 to get from 13 to 15? Yes, I can. And I can add 2 to get from 15 to 17. So the common difference is 2. Now, we have a formula that's called an explicit formula. An explicit formula defines each term in a sequence. It allows us to calculate any term in the sequence without knowing the value of the previous term. All right? It's called the explicit formula. So the explicit formula of an arithmetic sequence is this. I want you to take a minute to write it down. a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. All right, we need to define each part of that explicit formula. So give yourself a little space. If you need to rewrite it, go ahead and do that. And a sub n, we just stated, was the nth term. A sub n is the nth term. A sub 1 is going to be the first term. Okay? And then we have n is going to be the term number, and d is going to be our common difference. All right, so now let's go ahead and we're going to use the explicit formula to find any term in the sequence. All right, so here is our arithmetic sequence, 11, 13, 15, 17. We decided it was arithmetic because there was a common difference of 2. All right, so we do need to find, in order to find the 100th term, we need to know the first term and the common difference. All right, so we're going to find the 100th term. So this is how I'm going to write it. A sub 100, meaning I want to find that 100th term. All right, that's equal to the first term, which was 11. 11 is the first term in our sequence. Plus, we're trying to find the 100th term, but we're going to do 100 minus 1, okay, times the common difference of 2. So a sub 100 is equal to 11 plus 100 minus 1 is 99 times 2 is 198. All right, I subtracted 1 from 100, got 99, and multiplied by 2 and got 198. So our 100th term, if we were to list out this term, or this sequence, and we went to the 100th term, remember our first term was 11, and we went out 100 different times, we would get 209. All right, so now I have a new sequence, and I want you to take on your paper, at the very top of your paper, there were the 11, 13, 15, 17 was there, and then there was a different sequence. Could you cross that out, please, where it says 5, 15, 45, and 135? Cross that out, and I want you to write 3, 8, 13, 23, 28, 33, and 38, and then an ellipsis, dot, 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 okay? All right, so I always, if I'm going to be writing the explicit rule or I'm finding some kind of rule, I write it down. And remember that the rule for to find the explicit rule is this: a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Now I always have to know the first term. The first term in this case is 3. All right, and the common difference, if I went, how did I get from 3 to 8? I added 5. From 8 to 13, I added 5. From 13 to 23, I added 5. Just keep double checking to make sure that you can get from one term to the next by adding 5. And yes, you can. All right, so now I want to write the rule. I'm not ready, or I'm not done yet. I haven't written the rule. All I've done is I've written a general rule, a generic rule, to find the term of any sequence. So now I'm going to replace a sub 1 with 3 and d with 5. Okay? So you might think that you're done, But when you have to write the rule, it could be written like this. And if you were given multiple choice, yes, this could be the rule. But look at that 5. I can distribute that 5 to everything on the inside of the parentheses. So I can take 5 times n and 5 times 1. All right, so now I have here a sub n is equal to 3 plus 5n minus 5. I'm still not done because now I can combine like terms. And when I do that, I get a sub n is equal to 5n minus 2. And that is my rule for an arithmetic sequence. A sub n equals 5n minus 2. All right, now if I look at my directions said find the 33rd term. Well, now because I have narrowed down my rule here to a sub n equals 5n minus 2, all I have to do is replace n with 33. So now I have a sub 33 is equal to 5 times 33 minus 2. All right, and when I do that, I get 165 minus 2, which is going to be 163. So my 33rd term of this arithmetic sequence is 163. All right, that was an arithmetic sequence. We're now going to move to geometric sequence. If you need to pause the video and think about what you've learned here today and go over a couple of things in your head, go ahead and do that. Otherwise, we're going to move to the next paper, which is geometric sequence. Okay, geometric sequence, like an arithmetic sequence, changes by something common, but it's not a common difference, it's a common ratio. All right, remember ratio can be written in terms of A over B or as a fraction. So a common ratio is the amount we multiply by, all right, in this geometric sequence. So let's look at this sequence: 2, 10, 50, 250. Okay, so I've told you it's geometric, but how would I know? Well, I might be able to see in this one that I'm multiplying by something every single time, but just say, what if I can't? Well, what I like to do is I like to start with the last two terms, the ones on the right, okay, and I'm going to divide to find the common ratio. In this case, the last two terms are 250 and 50. All right, so if I do 250 divided by 50, I get 5. So now I have to double and triple check that every time I multiply by 5, if I can get the next term in my sequence. Well, so I'm going to start back at the beginning now. 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. Yes, so my common ratio, R, I'm going to call it, is equal to 5. All right, so now let's look at this geometric sequence. I have here 135, 45, 15, and 5. Let's review what I did in the last one. I said the last two terms, okay? That's where I like to look on the far right. So our 5 and 15. Okay, but remember we're looking for a common ratio. That can be written as a fraction. So I'm going to divide 5 divided by 15, and that is equal to 1/3. So my common ratio here is 1 over 3. Okay, so just kind of keep that in mind, that it can also be a fraction. So I'm multiplying by the fraction 1/3 to get to the next one. So 135 times 1/3 is 45, times 1/3 is 15, times 1/3 is 5. times 1/3 is going to be 5/3. All right. We have an explicit rule for the geometric sequence as well. Remember, the explicit rule lets us find the next term no matter what. We don't have to know the previous term. So this is what the explicit rule for a geometric sequence looks like. A sub n is equal to a sub 1 times r, remember that's our common ratio, raised to the n minus 1 power. A sub n is equal to a sub 1 times r raised to the n minus 1 power. Okay, a sub n is still the nth term. A sub 1 is the first term. R is my common ratio. And n is still the term number. Okay? Alright, so a sub 1 is equal to 3 in our geometric sequence. And the ratio, well, let's look at 27 and 9. And 27 divided by 9 is 3. So my common ratio is 3. Alright, now to write the rule, alright, I'm going to replace a sub 1 with 3 and r with 3. So my rule looks like this. A sub n is equal to 3 times 3 raised to the n minus 1 power. Now, in the arithmetic, we went ahead and we simplified. But in geometric, we are not going to simplify. We need to leave that as is because of that 3 being raised to the n minus 1 power. So do not multiply the 3 times the 3. Do not, do not, do not. Leave it 3 times 3 raised to the n minus 1 power. All right. So we want to find the 7th term of that sequence. All right. So remember we had here the a sub n was equal to 3 times 3 to the n minus 1 power. So now I have replaced the n with 7. Okay. So a sub 7 equals 3 times 3 raised to the 7 minus 1 power. So that means that a sub 7 is equal to 3 times 3 to the 6th power because 7 minus 1 is 6. All right, you are going to need your calculator. And remember that it's not 3 times 6, it's 3 times itself 6 times. So 3 to the 6th power and is going to be 729. So 3 times 729 is 2,187. So the 7th term of this geometric sequence, 3, 9, 27, is 2,187. All right, so now we're going to look at this sequence, 400, 200, 100, and we are going to write a rule and find the 7th term. All right, so we always have to write what is the first term and what is the common ratio. So the first term is 400, all right? The common ratio, remember I'm going to the very far right and I'm doing 100 divided by 200. 100 divided by 200 and reduce that, my common ratio is 1/2. Let's make sure it works. 400 times 1/2 is 200. 200 times 1/2 is 100. Okay, so it does work. I checked it out. And now I'm going to replace the first term, a sub 1 with 400 and r with 1/2. And this is what I'm going to get. All right. Now, if I was doing real world, I would go ahead and take the 1/2 and turn it into a decimal. But I'm just going to leave it that way for now. All right. Now, remember that in this geometric sequence, my numbers are getting smaller. All right. So to find the 7th term, I'm going to take a sub 7 is equal to 400 times 1/2 raised to the 7 minus 1 power. So 400 raised or times 1/2 raised to the 6th power. Now I'm just raising that 1/2 to the 6th power. So I learned that I can take 1 to the 6th power and 2 to the 6th power, which is going to be 400 times 1 over 64. Okay? Now, when I do that, I can reduce and take 400 over 64 and reduce it. I'm going to go ahead and just do 400 divided by 64. So my 7th term of that sequence is going to be 6.25. All right? Okay, we learned a lot today. So I want you to take a few minutes and digest what we've learned. We've learned the explicit rule for both arithmetic and geometric sequences. And we learned how to write subscript. And that's all for today. So until tomorrow.